placement of electrical conduits in the flutes or channels of roof decks presents a notable safety concern, especially considering the common practice of using roofing screws for system attachment. The experiences highlight the potential for accidents and underscore the urgency of addressing this situation. A key consideration is the required penetration depth for roofing screws, which is essential for securing roofing systems. When conduits are present in the flutes, they obstruct the screws, potentially reducing their penetration and creating weak spots in the roof. This obstruction can compromise the integrity of the entire roofing structure. One of the most pressing concerns is the safety risk posed by roofing screws coming into contact with the electrical conduits. Such contact can lead to short circuits, sparks, and even electrical fires. These electrical events can have severe consequences, including life-threatening situations for those working on or occupying the building. To address this issue effectively, it is necessary to implement clear guidelines and best practices for the placement of both electrical conduits and roofing screws. Firstly, prohibiting conduit installation in flutes is paramount. Building codes and electrical standards should be amended to explicitly forbid the installation of conduits within the roof deck flutes. This prohibition ensures that the path of roofing screws remains clear and unobstructed. Secondly, designating alternative conduit locations is crucial. Instead of placing conduits in the flutes, alternative routes should be specified. These routes can include running conduits along the sides of the roof structure or within the rafters. By providing alternative pathways, the risk of interference with roofing screws is minimized. Thirdly, enforcing code compliance is essential. Building inspectors and electrical contractors must rigorously enforce code requirements and best practices related to conduit placement. This enforcement ensures that conduits are installed in safe and appropriate locations, adhering to established standards. Fourthly, educating contractors and electricians is vital. Training sessions and workshops should be conducted to raise awareness of the hazards associated with conduit installation in flutes. These educational initiatives should inform contractors and electricians about proper practices and the importance of avoiding hazardous placement. Fifthly, collaboration and communication between roofing contractors, electricians, and building officials are crucial. Open dialogue and coordination during the design and construction phases can prevent the installation of conduits in hazardous locations. This collaborative approach ensures that all parties are aware of potential risks and work together to mitigate them. From a legal standpoint, building owners, contractors, and electricians could face liability for injuries or damages resulting from unsafe conduit placement. Establishing clear guidelines and following best practices can help mitigate these legal risks by demonstrating a commitment to safety and compliance. The use of specific National Electrical Code, or NEC, articles may be applicable. While a complete NEC analysis would depend on the specific installation details, some relevant sections might include those addressing wiring methods, support requirements, and clearances. For example, NEC Article 300.11 addresses securing and supporting wiring methods, which could be relevant to how conduits are installed in relation to the roof deck. NEC Article 310 covers conductors for general wiring and related ampacity correction factors if conduits are bundled together. Also, ensure the voltage drop does not exceed NEC recommendation of 5% for feeders plus branch circuits to ensure proper performance of equipment. NEC Table 310.15 provides ampacity tables for conductors and is essential for determining the appropriate wire size based on the load and ambient temperature. When installing electrical systems in metal buildings, grounding and bonding are critical for safety. NEC Article 250 provides detailed requirements for grounding and bonding, including the proper methods for grounding metal enclosures and equipment. When installing conduits, it's important to ensure they are adequately supported to prevent sagging or damage. NEC Article 352.30 provides requirements for supporting rigid PVC conduit. For IMP, refer to NEC Article 358.30, and for flexible metal conduit, NEC Article 348.30. The spacing between supports depends on the conduit size and type. Proper conduit fill is essential to prevent overheating and ensure easy wire pulling. NEC Chapter 9 Table 1 provides conduit fill requirements. Exceeding the maximum fill percentage can lead to insulation damage and reduce conductor ampacity. When routing conduits through or near structural members, such as bar joists, it's crucial to maintain proper clearances to avoid compromising the structural integrity. Consult local building codes and structural engineering guidelines for specific requirements. Where conduits are exposed to physical damage, they must be protected. NEC Article 300.4 addresses protection against physical damage and requires the use of appropriate enclosures or guards. In environments with corrosive conditions, such as coastal areas or industrial facilities, use conduits and fittings that are specifically listed for use in those environments. NEC Article 300.6 provides requirements for protection against corrosion. For outdoor installations, use weatherproof enclosures and fittings to protect against moisture and environmental factors. NEC Article 410.10 provides requirements for luminaires in wet or damp locations. When installing conduits in accessible attics or roof spaces, protect them from physical damage. NEC Article 320.23 provides requirements for installing armored cable in attics and roof spaces. Ensure that all electrical work complies with the latest edition of the NEC and any local amendments. Local codes may have additional requirements beyond the NEC. Before starting any electrical work, obtain the necessary permits from the local building department. Permitting ensures that the installation will be inspected and meets all applicable codes and standards. Regularly inspect electrical systems to identify any potential issues such as damaged conduits or loose connections. Promptly address any issues to prevent electrical hazards. When making any modifications or additions to an existing electrical system, ensure that the changes comply with the current electrical codes. Improper modifications can create safety hazards and code violations. Consider using surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection can help prevent damage to equipment and reduce the risk of electrical fires. When working on or near electrical equipment, always follow lockout/tagout procedures to de-energize the circuit and prevent accidental energization. Lockout/tagout procedures ensure that the equipment is safely isolated before any work is performed. Verify the voltage and current ratings of all electrical components to ensure they are compatible with the system requirements. Using components with incorrect ratings can lead to equipment failure and safety hazards. Use appropriately sized conductors and overcurrent protection devices to prevent overheating and electrical fires. NEC Table 310.15 provides ampacity ratings for conductors, and NEC Article 240 covers overcurrent protection. Properly terminate all electrical connections to ensure a secure and reliable connection. Loose connections can cause overheating and arcing, which can lead to electrical fires. Clearly label all electrical panels and circuits to facilitate troubleshooting and maintenance. Proper labeling helps prevent accidental disconnection of critical circuits. When installing electrical equipment, ensure adequate ventilation to prevent overheating. Overheating can reduce the lifespan of equipment and increase the risk of failure. Consider using energy-efficient lighting and equipment to reduce energy consumption and lower utility bills. Energy-efficient technologies can save money and reduce the environmental impact. Regularly test ground fault circuit interrupters, or GFCIs, to ensure they are functioning properly. GFCIs protect against electrical shock by quickly disconnecting the circuit when a ground fault is detected. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools, when working on or near electrical equipment. PPE helps protect against electrical shock, burns, and other injuries. When running conduits in concrete, use corrosion-resistant materials and ensure proper encasement to protect against moisture and chemical attack. Concrete can be corrosive to certain metals, so it's important to use appropriate materials and installation techniques. Use proper grounding techniques to minimize the risk of electrical shock and ensure the safe operation of equipment. Grounding provides a low resistance path for fault currents, which helps protect against electrical hazards. When installing conduits in hazardous locations, such as areas with flammable gases or vapors, use explosion-proof equipment and follow all applicable codes and standards. Hazardous locations require specialized equipment and installation techniques to prevent explosions and fires. When working on or near energized electrical equipment, maintain safe working distances to prevent accidental contact. Safe working distances depend on the voltage level and the type of equipment. Consider using arc-resistant switchgear and equipment to protect against arc flash hazards. Arc-resistant equipment is designed to contain and redirect arc flash energy, which can reduce the risk of injuries and equipment damage. Implement an electrical safety program to promote safe work practices and prevent electrical accident. An electrical safety program should include training, procedures, and audits to ensure compliance with safety regulations. Regularly audit electrical systems to identify any potential hazards or code violations. Audits can help identify and correct issues before they lead to accidents or equipment failures. When designing electrical systems, consider future expansion needs and provide adequate capacity for additional loads. Planning for future expansion can save time and money in the long run. Use properly sized junction boxes to provide adequate space for making connections and prevent overcrowding. Overcrowded junction boxes can lead to overheating and insulation damage. Clearly mark the location of underground electrical cables and conduits to prevent accidental damage during excavation. Marking the location of underground utilities helps prevent damage and ensures worker safety. When installing conduits in areas subject to vibration, use flexible connections to prevent damage to the conduits and equipment. Flexible connections can absorb vibration and prevent stress on the system. Ensure that all electrical equipment is properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. Listing and labeling ensure that the equipment meets safety standards and is suitable for its intended use. When installing electrical systems in healthcare facilities, follow the additional requirements specified in NEC Article 517. Healthcare facilities have unique electrical requirements to ensure patient safety. Use properly sized transformers to provide the correct voltage levels for different types of equipment. Transformers are essential for stepping up or stepping down voltage to match the requirements of the load. When installing electrical systems in data centers, provide redundant power supplies and backup generators to ensure continuous operation. Data centers require highly reliable power systems to prevent downtime and data loss. Consider using power quality monitoring equipment to identify and address any power quality issues, such as voltage sags, swells, or harmonics. Power quality issues can affect the performance and lifespan of electrical equipment. When installing electrical systems in industrial facilities, use robust and durable equipment to withstand the harsh environment. Industrial environments often have unique challenges such as exposure to chemicals, vibration, and extreme temperatures. Use corrosion-resistant hardware and fasteners to prevent rust and deterioration in outdoor or damp environments. Corrosion can weaken connections and lead to equipment failure. When installing conduits in direct sunlight, use UV-resistant materials to prevent degradation and cracking. UV radiation can damage certain types of conduit and fittings. Clearly identify and label all disconnect switches and circuit breakers to facilitate troubleshooting and maintenance. Proper labeling helps prevent accidental disconnection of critical circuits. When installing electrical systems in agricultural buildings, follow the additional requirements specified in NEC Article 547. Agricultural buildings often have unique electrical requirements due to the presence of dust, moisture, and corrosive chemicals. Use ground fault protection for equipment to protect against electrical shock and equipment damage. Ground fault protection can quickly disconnect the circuit when a ground fault is detected. When installing electrical systems in swimming pools, spas, and hot tubs, follow the additional requirements specified in NEC Article 680. Swimming pools, spas, and hot tubs have unique electrical requirements to ensure swimmer safety. Use tamper-resistant receptacles in areas accessible to children to prevent accidental electrical shock. Tamper-resistant receptacles have shutters that prevent objects from being inserted into the slots. When installing electrical systems in marinas and boatyards, follow the additional requirements specified in NEC Article 555. Marinas and boatyards have unique electrical requirements due to the presence of water and the potential for corrosion. Use surge arresters to protect against lightning strikes and voltage surges. Surge arresters can help prevent damage to equipment and reduce the risk of electrical fires. When installing electrical systems in mobile homes and recreational vehicles, follow the additional requirements specified in NEC Article 550 and 551. Mobile homes and recreational vehicles have unique electrical requirements due to their compact size and mobility. Use arc fault circuit interrupters, or SIs, to protect against arc faults, which can cause electrical fires. SIs detect arc faults and quickly disconnect the circuit to prevent a fire from starting. In summary, addressing the issue of electrical conduits and roofing flutes requires a multifaceted approach. This includes amending building codes, enforcing compliance, educating stakeholders, and fostering collaboration. By working together to implement these measures, the roofing industry can create a safer environment, prevent accidents, and protect the integrity of roofing systems.